Hi, Lorenzo. Niklas here.
Hey, Niklas. Welcome.
Thank you.
Okay, it's actually time for starting. I'll wait maybe 1 minute or two more to wait for more audience, and then we can start. Okay, it is 2 minutes past, so we can start. Welcome everyone to this third interim meeting of 2025 of the ASDF working group. I'm Lorenzo Corneo, and today I'm presenting on behalf of my co-chair Michael Richardson also. Yeah, so let me start by presenting the agenda for today. Here you find some relevant links, like the note well to the IETF website, where we can take notes. I think Ari is taking notes today. Is it, Ari?
Yes.
Thanks a lot. I really appreciate it. Okay, and then I'll briefly give a working group status update. And then on the agenda, we have some quick NIPSI updates. The authors are not here, but I'll go through a list of changes for the new version of the draft. And then we have a quick discussion about the SDF link that has been called for adoption recently. Then we have updates presentation for the digital twin draft and the non-affordance one. And then we have some time for discussing the newly submitted internet draft about instance information from Karsten and Jan. And then another business on top of my mind, there is the face-to-face meeting in Madrid. Should we do it or not? And also when will be the next virtual interim meeting? And if I forgot something, please type in the chat, and then we will try to fit it at the end. Any question? Okay, then I go on briefly through the note well. This meeting is recorded, so be nice and professional. Otherwise, there may be a notification to the IETF code of conduct. And please follow the IPR guidelines for the IETF, and you can find links, more details in the links. Repository link and notes are here on the screen. You can get the slides from the data tracker in case. And these are more details on the note well and code conduct. I will not go through them in this presentation. Just be aware they are there, and for more information, you can just go into the slides and click. Yeah, so status update on the working group. Yeah, as you all know, the the working group was chartered in October 2020 and rechartered in June 2024. Chairs, it's myself, Lorenzo, and Michael Richardson, and before also Nicholas was part of the chairs. Thanks for the great work done until March 2025. And the progress so far. So SDF has been approved by ISG as proposed standard. Very well done, authors, Karsten, Michael Koster, and Ari. Yes, Karsten. Karsten, there are some problems. We just hear noise. Not getting better. Yeah, I guess Karsten is trying to fix audio. So maybe I go forward and then Karsten can chip in again. Yeah, so we have a new version of the NIPSI draft, the 04 currently, good progress. And also we have new version of the digital twin internet draft, 7th version. Then we also have ASDF link that has been called for adoption by the working group. And we have 2 new drafts on non-affordances and instance information. Yeah, so here a brief update on the NIPSI work. There is a new version available, the 04. There have been lots of changes. So all our feedbacks from previous meetings and hackathons have been incorporated in the draft. You find the relevant links here in the slides. And for your information here, a list of all the major changes that have been brought to the 4th draft. So now I think it's time for the SDF link discussion. Karsten, can we try again with the audio? Yeah, okay, I'll just move on. So maybe we can take the digital twin update. So I load the slides and then.
Can you hear me now?
Yes, Karsten, yes.
Okay, I'm using a slightly worse microphone. I hope it's not too bad. So I just wanted to quickly mention that when we submitted the SDF draft to the ISG and landed in the RFC editor queue, usually IANA looks at the document and does the registry actions. And we found a bug in the references to those registry actions. So a few things still happen in the background. So the reference to CNML that should have pointed to CNML units actually went to CNML names, which we don't use. So just as a little information of things that are going on in the background.
Thank you for clarifying this, Karsten. Now on the agenda, there is the discussion about SDF link. So would you like to share something with us?
Okay, I didn't make slides. We are in a working group adoption call, which will end on Friday evening. And I just wanted to have an item on the agenda that reminds us of that. And if there's anything that already can be said, I mean, this is a confirmation call, so no answer is a good answer. But we still have 48 hours and a couple to go. So if anybody has anything on this would be a good time to bring it up. Otherwise, probably the chairs will adopt it by the end of Friday.
Thanks, Carsten. So anyone, any inputs?
Yeah, so I think it's technically good document for the base of adoption, so fully support that. I mean, of course, if we do have time today, we could maybe discuss some of the design choices, but maybe that can be at the end of the meeting if there's time.
Okay, yeah, it makes sense. So let's have it in the end. Next on the agenda, we have digital twin. So Young, I am giving you control of the slides.
Okay, thank you.
Okay, does it work? Awesome.
Okay.
Okay, yeah, stage is yours.
Okay, thank you. Hello, everyone. First of all, thank you, Lorenzo, for your quick processing of several requests for my presentation material. I will have a short talk for the document titled ASDF Modeling for Digital Twin version 7. In this version 7, we have mapped the information attributes of digital twin to the classes of ASDF thing. Table 1 shows the mapping the information attributes in ISO 23247 Part 3, the digital twin standard, to the classes of SDF. The mapping in this version may be modified and reflected in the next contribution as shown in this slide. The relationship may also vary depending on the document state of a large document, the extended relation information for semantic definition format. From what I understand, one SF thing can have both the attributes of SF non-affordance and affordance, and the other SF thing can have the attributes of SF non-affordance only. For example, a sensor that can connect to the internet can have both the SF non-affordance and affordance, and the table or head that cannot connect to the internet can have only the SF non-affordance. In this version 7, we mapped the class of SF with the information attributes of ISO 23247 Part 3, the digital twin standard. In the future, we are planning to develop the examples and guidance for modeling and registering the SDF to represent SDF thing as a digital twin, and the mapping with IETF 4605, the digital twin federation. Thank you for your attention. Thank you. Do we have any questions?
Thank you, Young, for the presentation. Anyone from the audience? Ari, go ahead.
Yeah, I guess can you flip one or two slides back? So you mentioned here about the relationship part. I think I missed about that one. Can you repeat what you had in mind?
The relationship is defined in an extended relation information for semantic definition format by large document. Do you know that?
Yes, and did you have some? Yes, I was wondering, did you have some specific considerations? Because actually, when we started that work on the SDF relation, actually, digital twins was one of the kind of key use cases that we had in mind. I was wondering if the new version of the draft had more considerations on that. Unfortunately, I didn't have a chance to read it yet. But if there's more on the SDF relations that you are now using, that would be interesting to hear.
right? In my understanding, the relationship document may be used in my document. So it may be vary depending on the document state of Lattice document.
Yeah. Okay, thanks. Maybe it's easy. I'll take a look at the draft and then we can take a chat offline.
Okay, thank you.
Thanks.
Thanks, Ari. Anyone from the audience? Okay, no more questions from the audience, so I move on. Thank you so much, Young, for the updates. So next on the agenda is the non-affordances. So let me share the slides. Here we are, Yunga.
Yes, thank you. Can you hear me?
Yes, loud and clear. I'm going to give you control of the slides now.
Okay, thank you. Okay, hello everyone. I'm Jung-Ah Hong from Ed3, and I'm introducing our draft titled ASDF Extension for Non-Affordance Information, which defines a simple extension to the ASDF that enables the inclusion of non-affordance attributes into thing description. And this is the motivation and definition. And the current SDF has been effective in modeling affordance, which is the interactive capability of things such as the properties and actions and events. However, in many real-world applications, devices also require additional non-interactive metadata like their location or dimensions or manufacturer details. Without a standard way to include this in SDF, the device models may be incomplete and harder to integrate across systems like digital twins or asset platforms. So we try to address this gap. So we define the non-affordance as attributes of a thing that are not directly related to its interactive capabilities. This includes the scriptive metadata such as location, manufacturer details, and other contextual information. These are essential for understanding and managing devices, even though they're not part of the real-time interaction. And here gives a quick 3 use cases for non-affordance. The first one is asset tracking. In logistics, the containers or equipment of needs to report things like size, weight, and location. They are not interactive properties, but they can be crucial. So the non-affordance, SDF non-affordance can give us a clear way to include that data in the model. The second use case is smart buildings. So knowing where a sensor is installed or what room it's in or how it's mounted make a big difference for automation and energy control. So that is a contextual information and it can fit well under the non-affordance. And third use case is the regulatory compliance. Devices in regulated environments need the metadata like model numbers or firmware version and certifications. So putting this in the SDF model can help us audits or maintenance and even recourse. And this is the main proposal in this draft. So we address to this gap. We are proposing a new class called the ASDF non-affordance, and it can be used inside SDF theme or SDF object, and follows a simple structure, which includes name, type, description, and unit. And these are aligned with the existing SDF model and support schema validating and tooling you reuse. And this is a simple example on geospatial information. So under the SDF object, we define the tracker device, and then SDF non-affordance, and then attribute location with the description and types, and the WGS 84 as an object. And yeah, this is a simple example. And this is all about it today. Thank you. Any questions?
Thank you, Yunga. Thank you. Carsten.
Yeah, thank you for this presentation. I was wondering, what are the structural differences, or maybe they are the same, between SDF non-affordance and SDF property? So this looked a lot like an SDF property modeling. And what we tried in our document, which we will come to next, was to actually make them as similar as possible, but you have thought a lot more about this, so maybe that was not such a great idea, and I would like to hear from you if that is the case.
Yes, I think we proposing to use the new class named SDF non-affordance instead of the properties. But
right.
Yeah. Go ahead. Thank you.
The question was, does this generally look like an SDF property? I mean, if you look at SDF event, that looks a lot like an SDF property. I mean, these are different things, but they look the same. They have the same structure. And I'm just wondering whether SDF non-affordance would also have the same structure as the other two. Maybe we can pick this up again when I'm showing my slides, because I have an example, and then maybe it's easier to react to the example than ask this.
Maybe a counter question to you, Carsten. So if it does not behave as an SDF property, how much changes should be done on the SDF part or on the CDDL definition?
Yeah, that's indeed a good question. Again, if you look at SDF property and SDF event, they have exactly the same structure. They behave differently because one is about the request response situation and one is about the notification situation. But the structure of the model is the same.
I see. So would it be correct then to reuse the grammar for properties and events if the semantics is actually different? Because syntactically it would make sense, but would it semantically?
Well, semantically it's a data type description, How this data type description is actually used makes a difference, but that doesn't have any influence on the structure that the CDDA description provides.
Thanks. Makes sense. We have Young Jong.
Yes. Thank you, Karsten. This document follows the structure of the SDF document. Here, in this document, SDF non-avoidance includes the different information. For example, it includes the location information of tables or heads, things like that. The thing that cannot connect to the internet. The SDF non-avoidance deal with the information for the things that cannot connect to the internet. For example, tables, chairs, heads, things like that. It's our understand. Thank you.
Yes, thank you. So yeah, let me show this with the example I have on my slides, and maybe I can ask the question in a slightly easier to answer way.
Right. Any more question on the non-affordances from the audience? Okay, so if no more questions, we can move to the next item on the agenda, which is the instance information draft. So Karsten and Jan wanted to have a discussion around this. So I'll go on and share the slides, Karsten.
Yes, please.
Yeah, just a second. Slides. Yep. Let me give you control. You should
Thank you.
be set.
Got it.
Okay, great.
So in the last couple of days, Jan and I had an interaction on maybe writing up our ideas on instance information. And this is all very much fluid at this point, but I would like to present a snapshot here. So first, a few general things ahead. SDF really is a language to describe an interaction model. So it describes how would you talk to your refrigerator to get the temperature inside. The interaction always is something that we would call data at rest. So the refrigerator sits there and has a temperature. And we interact with it by exchanging messages. So we're sending a message asking for the temperature, and we're getting back a message that contains the temperature. And what we mostly do in the interaction model is describing data in flight. So SDF data really is a way to write down the data structure that is being sent. And for instance, for an SDF property, we only describe the data structure that is being returned. So we are not describing how you actually ask for a property. We are only describing how it looks like when you get it back. And that's true of properties, actions, and events, the three main affordance types we currently have. So properties only have an output parameter, actions have an input and an output parameter, and events only have output parameters again. So for all these parameters, we can use the same data modeling mechanisms. So we save a lot of effort by not inventing a new data modeling mechanism for a new kind of affordance. Now, the important thing to keep in mind is this is abstract modeling. So we are trying to be this little red star in that figure where all the various ecosystem implementations of this abstract model come together in a common data model, or actually it should be called interaction model. So we always know there are ecosystem specifics that may be different between a property and an event with respect to the output parameters, but we still can model them the same in the abstract. So all I'm going to talk about now is the abstract modeling, and I'm very well aware that this is going to feel very different when we add the ecosystem specifics. Okay, so that's the first thing I wanted to explain. Then I wanted to quickly go back to February 25th. There we had a discussion about SDF non-affordance. And one thing that, these are actually my slides from February. One thing that came up is, should we maybe just call it SDF off device? And otherwise treat it like an SDF property. So I asked essentially the same question I have been asking today. And we noticed it would be really good to have off-device information models collected somewhere. So we can do things like location and serial numbers and so on, SKUs, and have standard models for those. Okay, that was the state 6 weeks ago. And yeah, we had an IETF and lots of other distractions, but now we've finally started writing this up. And the one other thing we need, apart from actually modeling this thing, is to actually write up an instance. So that will be on one of the following slides. Right now, I'm talking about modeling. So we don't have a specific location. We're just describing how does a location actually look like when it is made available using an affordance, using context information in some way. And yeah, it turns out that doesn't really look very different for a location than it does for other things, for other affordances. So calling this non-affordance information may be a little bit confusing because, for instance, your digital twin may have an affordance that actually allows you to access the location. So it's not really non-affordance, it's just off-device. So yeah, we decided to just add a single quality called off-device, and that can be true or false. That's very crude. We probably want to be more specific about which various way to talk about this thing have it and which don't have it. But right now, just for this discussion, it's sufficient to have an off-device quality that can be true or false, and here it's actually set to true. So otherwise, these things are isomorphic to other SDF properties. So for instance, if you look at the SDF data declaration for the data type of a location, this looks like your standard SDF data declaration. So we say it is of type object. Objects have properties, so we list the properties, and one is WGS84 and the other one will be the postal address or something like that. So we can just model this exactly the same way. And of course, this has a secret advantage for us because all of our tools will just work. We will have no additional work except for this new off-device quality, which we may need to process, but that may be very easy. Okay, so this is the approach, but I'm actually not talking about instance information here. I'm still talking about the model. And now the question is, how does instance information actually look like? And that is very drafty right now. So we may want to change this, but just as a way to talk about it. So instance information gives you information of what we know about an instance. For instance, an instance could be the thing itself. That's definitely an instance. There might be an instance in digital twin. There might be an instance in the property management system. There and the asset management system. There may be an instance in the network management system and so on. And we want to be able to talk about the information that is in those instances, and to no longer talk about models, classes of items, but to talk about a specific instance. We just decided to put in SDF instance, and this is all very hand-wavy here. But when you take it from there, you can essentially do the same structure you would do on the modeling side, except that we have a pointer from the instance data tree to the model tree. So for instance, this SDF instance, which is called boat 007, says, oh, by the way, I am a models SDF thing boat. So you can find all the information about me there. So I don't have to repeat model information in the instance, which I think is pretty important once you have more than a few items of every kind. So in the boat, there's another instance of a heater, and that has a different model describing it. It also has a context. I have no idea whether we will stick with $context, but for right now, just think about $context as another SDF property that you would have in the instance. And the value of that property is this user ID here. So the scheme object ID that we would use for managing the access control, that could be encoded as context information in the instance information. And then the next piece of instance information we have is the location. And here again, we are not describing the model. The model said that WGS84 is a type object with certain properties. Here in the actual instance information, we just write the data. So latitude is 35 and longitude is 129 and altitude is 0. And we have postal information as well. So to fit this on the slide, I cut it off here. So instance information looks very different from class information, but we have harmonized the class information so it looks the same for both what we call non-affordance, or what we now call off-device information, and for information that is actually offered as an affordance by the thing. So I started with the example. Now let's get a little bit more heavyweight here. So we need a little bit more terminology, because so far we only had terminology on the modeling side and not on the instance side. Yeah, the first term we don't need to define, representation, because that's defined in REST. This doesn't mean that all ecosystems need to be REST, but all ecosystems have something like a representation. So it's not wrong to put this into the red star. Then the next term is a message, which is essentially a representation that actually is being exchanged. So there is some interaction that wants this interaction for something, as in give me the current state of your temperature sensor or something else. So a message is instance information that is being exchanged. So the SDF model models the information that is being exchanged in interaction. So the SDF model provides the model for the messages, but it doesn't provide a way to write down those messages. And that's the missing thing. So being able to actually write down messages in an abstract fashion, not in an ecosystem-specific fashion, this will also have to come in at some point. That's the one thing we need to do. And the other thing is that we need to be a little bit more explicit about what instance we are actually talking about. And the assumption here is that all the instances that are interconnected to describe or support a thing are somehow bound together by some form of identity. So the thing itself and the digital twin have a way of knowing that they belong together. Maybe only the digital twin knows that it's the one for something and the thing is oblivious. But there is some identity information that is binding these together. We are not currently modeling that. May have to add that. But basically, the instances live in different embodiments in the thing itself, in the digital twin, in an asset management system, in a piece of paper that is pasted to the engine in a boat's motor room, whatever. These are embodiments of the instance, and some of these are more digital than others. So the interesting thing about instances is if you actually can address them, if you know how to talk to them, then of course you are better off than if it's just a piece of paper taped to a machine somewhere. So as soon as you can address it, you might be able to make up an interaction that allows you to access information from the instance in the form of messages. Okay, then we needed a term for something that most of us probably have in our minds very implicitly, but we need to make this explicit. When we think about a device that is sitting somewhere and providing interactions, we typically assume that we can read out that device. And if we read out all of the device, we have something that we have called a proof shot. And there is a reason why we invented a term here, because the proof shot is not the instance. It's a photo of the instance, and the information in the proof shot may be suboptimal in some way. First of all, it only gives you the state at a particular point in time, which again may be part of the context. But also it may not always be possible to get full information back from the device which state it is in. So you might have a switch that you can switch on and switch off, but you cannot ask, are you on or are you off? That's not a great design, but it's possible that we have switches like that. So a proof shot is essentially all the information we can get from the instance, keeping in mind that may not be all that needs to be known about the instance. So that's one interesting message that goes beyond what we currently have in our SDF models. But of course, if you have a device that has SDF properties for everything, you essentially have a complete recipe for a proof shot. You might have some concurrency problems there, but otherwise you know everything you need to do to get a proof shot, but it may be more complicated. So then reading a proof shot is a natural activity. Now the next question, of course, is, can I write a proof shot? And that may be a bit weird because some information in there may not be something that can simply be written. So just imagine, it's not going to be the case, but imagine this proof shot includes some key information, some encryption or authentication key that the device uses. So when you proof shot it, you might get this key back because your management system wants to know what it is to correct the encryption or whatever. But you cannot just set that because that key information is the result of a key establishment process that happens with a different entity. And you cannot just change that entity over there as well. They have to go through this process. So we distinguish a proof shot message from a construction message that has just the information that is needed for the creation of a digital instance, but is not trying to set things that cannot be set. So those people who think in Yang at this point may want to think about config false, config true, and all the interesting things that Yang has around that. So we won't get rid of that distinction. So we might as well start modeling it in the first place. Okay, so a construction message might be one that can be used for the initialization or commissioning of a device, or that could be used for, in setting up a digital twin of something by giving the digital twin an initial proof shot of what's in the device. So construction messages are like proof shots, but they are really geared up to setting the information, to instilling the information into a device or a twin, and not trying to read it from there, which may not give you a result that you can set back. Okay, so proof shots and construction messages are two terms that we need to understand what we might be able to do, and we haven't actually managed to put these into the models. We still need to understand how exactly you would do that, but it should be possible to model these things at some point. Okay, and here just to underscore this context thing once more, in the end, we can model the context as just another property, but it's not a property that you would actually normally interact about. It's something that is context. And as I said, one element of a context might, for instance, be the time at which an interaction actually happened. Yeah, this has a device name, which we just gave it a URL device name, and the EUI64 address and the SCIM object ID, and maybe also a pointer to the parent instance. So if this is for the heater, maybe you have a pointer to the boat in which the heater is installed. Yeah, this is not fully fleshed out, but this is of course what we want to do in the next couple of weeks. So my request would be, please check out the draft. Of course, ask questions now, but maybe you want to read that draft. There's one more thing in the draft, which is about deltas and default or base messages, which is even more nebulous than what I talked about. There are also some more examples in the draft that might help you build hypotheses for what the draft is trying to say and verify those hypotheses. And what we want to do next is take all the documents that we can find, including the two we just talked about, and translate the examples in those documents to the structure we have here. I want to check whether we interact in the right way with NIPSI, for instance, on the context level, and we want to do new versions of this document. You're done.
Okay, thank you. Thank you for your presentation with the digital twin example. And I think it's an appropriate document to model objects as a digital twin. However, since affordance is about interaction, ASDF of internet or ASDF of interaction is better in my understanding. What do you think?
Can you say the last sentence again? What is better?
Yes. My suggestion is that ASDF affordance is about the interaction. So instead
Yes.
of off device, SDF of internet or SDF of interaction is my understanding. Is better in my understanding. What do you think? Thank you.
Yeah, the interesting observation is that it's structurally the same. So we may want to exploit this likeness, even though we use the data in a different kind of activity. We are not using it as an affordance to the device. We are using it as information we receive from an asset management system or something like that. But in the end, the aspects of it we need to model are the same. So we might use the same structure in the modeling language to describe it. Jean-Marie?
Yeah, thanks a lot for documenting this, Carsten. I think there's a lot of these ideas that we have been discussing earlier in some context, like put together and a bit more. I had a question about perhaps it's about the proof shots. When I was thinking, like, what are the right ways to model the information, the current state? One approach that we have discussed earlier is, for example, using SendML for this, being kind of the streaming telemetry data style. Did you see that would be perhaps more for the interactive interactions, and these proof shots would be more like the, let's say, current state of all the actions, or how do you see them, different mechanisms playing together?
I should have made that 10th slide. A telemetry stream can be thought of, at least some of them, can be thought of as a sequence of deltas that update the proof shot. I have no longer seen 33 packets, I have seen 34 packets. That would be what you find in the stream, and the number of packets is part of the proof shot.
I see. Okay, is this more detailed in the draft?
No, but you can piece it together from what's in the draft. And so the draft currently just points to the serious transfer pattern that we have developed in the research group. And I think it would be a good idea to dive a little bit more deeply there and say how this fits together.
Okay, thanks. I'll take a look.
Okay. And John?
In digital twins, not only devices such as sensors, but also various tables, chairs, and windows exist. So off internet or off interaction seems better. How about you?
Yeah, we haven't really thought about modeling something like a room with all the physical things in it. Of course, you may want to know whether you have the right kind of chair in front of a management station where somebody needs to sit down, and so on. So there may be a lot of information that is off-device or non-affordance by nature that we want to have in our models. But we won't understand that until we have a good example. So this is also, again, something that I'm asking people to think about examples that we might want to translate into this model. Okay, Lorenzo.
Thanks for the nice presentation, Carsten. Very insightful. Maybe this question is more of a general one. So I've seen that you might get some recursion in the modeling, like the ASDF instance. So I was wondering if you've been considering about also the other end of receiving the model, like so the parsers that might get a bit overly complicated, and especially for very low-end devices, this might also be, a memory issue or even computation. Computation maybe not, but perhaps memory. Thanks.
Yeah, one of the aspects of this model is that any single instance doesn't have to have the whole picture. So the heater in this example doesn't have to have any idea whatsoever what your boat is. It just needs to be able to heat. So the instance that is on the heater can be very, very simple.
Okay, so basically you're saying that there's no need for parsing in there. You just get the reference and you fetch it somewhere else.
Yeah, something has to have the information that heater is in that boat. And that might be an asset management system. or it might be your network map. There are many places that may want to use this information. I'm sure that SCIM can already manage part of that information. But I think we don't have SCIM specialists in this meeting right now.
Okay, no, that makes sense. Thanks for the reply.
Harry?
Yeah, I think that what Lawrence was also commenting kind of refers to what we haven't described that well. It's like how do we use these models and what are the processing models that we have in our heads? Because all of us have different processing models that we have been talking about documenting. That might be something we maybe want to tackle in this group in not that distant future. Document the processing models for these documents now, including these new ways. I think that's going to be very helpful.
Good point.
And while I'm in the queue, I guess the two ways I've seen so far, like what I call the trivial ways of doing SDF instances, has been that you have somewhere an identifier and a reference to a model. And I guess like in this example that you have here, yeah, I sense that the instance of gives the reference and the name of that identifier now would be the boat 007 within a namespace that this instance is declared.
Yeah, so you might have more context information like the SCIM object ID. Yeah, I put this on the heater and not on the boat, but the boat might also have a SCIM object ID.
Okay, so it's the collection of these IDs that is in the end the globally unique identifier for this instance. I think that's something maybe.
Yeah, I'm not sure you always need the collection. Sometimes the top level will be enough, but that depends, of course.
Yes, and maybe that would be good to put somewhere in the draft. Like, what would the top level instance, like a single string, look like that you could drop around in your APIs? That hey, this is the instance I'm referring to. That you could then map back to something described here. Or are there some thinking?
Yeah, so the instance, if you talk about nesting, the instance contains other instances. And one interesting question is whether this is constituting the higher level instance or it's just its current state. So if I have a connector on my boat where I put this heater, the boat kind of is in a rather close relationship to the heater. On the other hand, if I'm trying to model a cantina on a boat and people go in there, the people don't suddenly become parts of the cantina. They are closely associated with the cantina by being in there, but it's a very different kind of relationship than between a boat and its heater.
Indeed. That sounds something like you would use some of the SDF relation to describe the more nuances of the relationship than just being part of. Yeah. So maybe that's another thing we should take a look together, the SDF relation and the instance information, and see like how do we describe things. Well, very good. Thanks.
That's a good point, because in this picture, the hierarchical relationship of the instance tree is not explicit. We talk explicit about the model tree. So there are two SDF instances of pointers that, of course, can have relationship attributes. But the structure of the instance tree is implicit. And we may want to have an orthogonal representation where it's explicit and we can put attributes on this relationship. So for a boat, one motor might be the motor that is currently active, and the other motor might be the standby motor. And that kind of relationship, you are the active motor, you are the standby motor for this boat, That may be one such relationship. But so far we have SDF relations just on the model level and not on the instance level. So we would need to understand how that works.
Exactly. So maybe that's another good thing to take a closer look soon. Thanks. But thanks, very, very good work.
Thank you. So again, I should point out that Jan, who is also in the meeting, did much of the work here. Just trying to acknowledge that.
Thank you.
Yeah, thank you, Carsten. Do we have any more questions? For the sake of timekeeping, we have 15 minutes left. So if there are no more questions, maybe we can go through the last items, which are basically when do we meet again as a virtual interim meeting, and should we meet face-to-face in Madrid? Right. Yeah. Thank you, Carsten, for the slides. Yeah. So anyone?
Yes, so definitely +1 for a face-to-face meeting in Madrid. I think that would be great, and I guess a lot of people in this group are planning to join. So I think that would make a lot of sense. And yeah, also having another interim before, especially for taking a look at the latest in the NIPSI, I think would make a lot of sense.
Thanks, Ari. So does this time works for everyone?
Yeah, maybe not so well for Michael, but I think generally it should work for Michael because he's on the East Coast.
Yeah.
So I think we have pretty much hit the sweet spot. I asked Yanda at the start of the meeting. It's 10 p.m. now in Korea, and it's 9 a.m. now on the East Coast of North America. So I think we are doing the right thing here.
10 p.m. is okay in Korea. Thank you.
Great.
Okay, should we then try to meet 1 month from now? Maybe just, how about like, for example, May 14th?
Looks okay.
So, May 14th.
The same time slot, I assume.
Yes, exactly. Okay, but then I can, if this is fine for everyone, I can then set it up.
Well, I think now we have Michael Costro, so maybe we can check right away.
Awesome.
So.
Hey, Michael.
Hey, sorry I'm late. I had another thing that I had already promised to do.
No worries. We are actually trying to find the next spot for the next interim. We said May 14th at the same time. Would that work for you? Might be a bit early.
May 14th is probably Wednesday also.
Yes.
Let's see, May 14th. I believe I am available on May 14th. Let me double check.
Yeah, that would be 5 a.m. for you.
Yeah, that's fine. I'm I'm up at 5 a.m. I just have another meeting, the weekly meeting I agreed to chair, but I think we have a slot on May 14th that's open. Let me just double check that. Quickly. Sorry. Yeah. Oh, no. See, I guess I'm not available. Well, actually, I can be available May 14th. Yeah, I'm available.
Okay, great. So then if I don't get any more objections, probably I'll make the logistics for the next meeting.
Yeah.
And then I guess face-to-face for Madrid it's a thumbs up. I plan to be there at least, and I hope to see many of you also. So I guess next meetings are set now. Any other business? Ari? Ari, go ahead. Yes. Ari, do you want to speak up?
Sorry, didn't find that. I pressed the wrong button.
No worries.
Yeah, so I think if we could perhaps spend a few minutes on the SDF type link. If there's something you want to show Karsten on the draft on that, but then again, we only have a few more minutes, so it might be easier for next time. What do you think, Karsten?
Yeah, I didn't make slides, but the basic idea behind SDF link is pretty simple. It's essentially taking the structure of a link that we have in the core link format and mapping that to SDF. So all the things you can do with a core link format, you can do with an SDF type link. And you can use the model to actually say, for instance, which of the target attributes you could put into a core link information piece need to be present, or to further restrict them in some form.
Yes, I think that's really good. What I was thinking, like, do we have a kind of convenient shorthand for especially the model translation use cases that we could design?
Yeah, that point. So of course this can use SDF-ref. So if the this is all the same, you could put the same into some SDF data thing and then just SDF-ref it from the various links. If you essentially need to run a little computation to build something like construct a URI from components, we cannot do that at the moment. But that's more like a general limitation of what SDF can do in SDF-ref thing. Sorry.
Yes. So we got to get a bit more detailed on that offline, but I think like maybe a bit of experimentation on the use of SDF-ref and type, and be able to do especially the model translation case for it.
Yeah. So this is again one case where it really helps to have examples, and we should try to collect examples to go into that document as well.
Okay, I think I can provide you a few, and maybe we can take the detailed discussion the next time. Very good, thanks.
Thank you, Ari and Karsten. I think I managed to request the next interim meeting. So I'll set up also the agenda down the line. Do we have any more final remarks before closing the meeting?
Thank you for a very good meeting.
Yeah, thanks, Ari. But then I guess we will close the meeting now. So thank you everyone for joining and participating. Thanks for good progress and good discussion. I'll be meeting you in May on the 14th. Thank you all. Have a nice day, night, depending on where you are.
Thank you.
Thank you. Bye.
Bye.
Thanks everyone. Bye.